You can start the session now.
So good morning. Am I audible?
Yes, ma'am.
Okay. So we had a lot of problems regarding thermodynamics. We could not understand the basics of thermodynamics, and I told that we will be restarting this chapter so that each and everyone can now get the basics of the thermodynamics. So let's start with the chapter of the thermodynamics once again. This time we already wasted a week on this. This time, if you face any problem or any doubts, try to speak for that problem then and there only. Or else I will be progressing through this chapter and you will be left with the doubts and ultimately you will not understand anything. Is this part, did I make myself clear? This time, please try to ask your doubts then and there only. It is thermodynamics. Okay. So what is thermodynamics? Thermodynamics is learning about the energy and the energy transformation. Okay. So it is learning about energy and energy transformation. Okay. So what is a system? So starting with the basic things, what is a system? System is a part of the universe which is under consideration. You, me, anything under study. That is your system. And what is the surrounding? Everything except the system. Okay. So that is the surrounding. So up to this, is this part clear? What is the system? What is the surrounding? If you are the system, then I become your surrounding. If I am the system, you become my surrounding. Is this part clear? Thing
Yes,
under
ma'am.
not consideration is the system, and everything except the system is the surrounding. And what is the universe? Universe is the system plus surrounding. Okay. It is the system plus surrounding. Up to this clear? Now,
Yes,
types of system. Okay. So what is the type of the system? One is the open system and second is the closed system. Third is the isolated system. What is an open system? Open system means like an open cup. Okay. It is like an open cup. Okay. So in an open cup, if the cup is open, you can add sugar to it. Yes or no? If the cup is open, you can add sugar to it. Okay? Just try to interact. Now, if this open cup of tea, of hot tea. Now, if you touch this cup, will you feel the heat? Yes or no? If you touch this cup, will you feel the heat? That it is hot, right? So this is an open
ma'am.
system where both mass and energy is being transferred. Mass, energy, both are being transferred. Okay, so this is an open system. Mass is transferred means in an open cup you can add sugar. Okay, so yes, you can transfer the mass. Energy is, if you touch the cup, you can feel that it is hot. So that is the transfer of energy. So in an open system, both the mass and energy can be transferred. Closed system means T in closed cup. Hot tea in a closed cup. Means on the cup you have put a plate. So can you transfer the mass? Can you now put sugar to it? No, because obviously the cup is closed. You have closed the cup with a plate. So that is the reason you can't add sugar to it. You have to remove the plate, transfer it to an open system, and then you can add a sugar to it. Okay, so mass transfer can't be done. But even if the cup has a plate on top of it and you touch the cup, you can still feel the heat, right? So obviously energy can be transferred. So that is the closed system. Is this part clear? Yes or no?
Yes, ma'am.
Good. And what is the isolated system? Tea in thermos flask. What is this tea in the thermos flask? Mass energy can't be transferred. Now, what is a thermos flask? Thermos flask, you have seen a flask, right? In a flask, people keep tea. So, it is a closed container type structure. So, obviously, you can't add sugar to the cup. So, mass can't be transferred. Now, no matter how hot the tea is, if you touch a thermos flask, you can't feel the heat or the coldness of anything. So that is the reason energy can't be transferred. Now, if you are telling, ma'am, after quite some time, after suppose 3 hours or 2 hours, even in the thermos flask, the tea becomes cold, right? So yes, so isolated system can be achieved for a very small interval of time. Okay, so this system can be achieved for a very small interval of time. Is this part clear? Is this three systems clear? Is this three system clear?
Yes, ma'am. Yes, ma'am.
Good. So for long and for the longer interval, this energy transfer will occur. Mass transfer will not occur, but for longer interval, this energy transfer will occur because after a some point, no matter the tea is in a flask or not, it will become cold. Okay, no system is isolated for long time. Okay, so remember one thing, walls of the thermoflask, it is an adiabatic wall, okay, where no heat exchange will occur. But walls of the cup, normal cup, that is a dithermal wall because energy is transferred there. Okay, so anything where energy is being transferred, that is called a dithermal wall, and the walls where the energy can't be transferred for quite some period of time, that we refer to as an adiabatic wall. Is this part clear? This whole thing, I guess you don't have doubts this time and everything is crystal clear to you, right? Now,
Yes, ma'am.
good. So now let's start with the properties of system. I will be teaching you a trick. You will be doing with that trick only. Properties of system. So there are two types of properties. One is the intensive. Another is the extensive. Okay. What is intensive? Intensive is mass and size dependent. This is mass and size independent. Okay, this is mass and size, sorry, I wrote the reverse. This is mass and size independent and this is mass and size dependent. Okay, so suppose consider a room. Okay, room has a volume, yes or no? Good. Now, it is, now suppose this is a room. Okay, this is your room. This room has a definite volume. Okay. Now, if you draw a wall here, now the volume of the room becomes halved. So previously, if the volume was 100, now this volume is 50. Here the volume is 50. Agreed or not? Agreed or not?
Yes,
Yes,
ma'am.
ma'am.
So
Yes, ma'am.
volume becomes an extensive property. So volume becomes an extensive property. Okay. Now, again, same room. Okay, same room. Now, here the temperature was 37 degrees Celsius. Now you have built a wall. So even if you build a wall in between the room, temperature remains 37 only, right? Temperature does not change. Will the temperature change if you suddenly build a wall in between your room? Will the temperature of the entire room change? No,
No,
right?
ma'am.
So temperature is an intensive property. So always think like this. It is a room, you build a wall in between. If the property changes, it is extensive. If the property does not change, it is an intensive property. Is this part okay? Clear? How you will solve? Clear? Up to this whole thing, how to distinguish between
Yes,
an
ma'am.
intensive property and an extensive property? For our sake of knowledge, I am giving you a list. Intensive. Properties example. Temperature, pressure, concentration, pH of solution, refractive index, EMF of cell, surface tension, viscosity, boiling point, freezing point. These are the examples. Extensive property. Extensive property is volume, mass, moles. U is the internal energy. H is the enthalpy or heat of reaction, whatever you call it. In the next class, I will not tell you what is U, what is H. S is the entropy. G is the free energy. C is the heat capacity. These are the common examples you will find in your exams. Remember, if one extensive property is divided by another extensive property, the product will be intensive. Okay. Suppose mole by volume is molarity, right? Mole by volume is molarity. You have learned in the first chapter. This is an extensive property. This is an extensive property. Molarity becomes an intensive property. And one more thing. If they are asking you about volume, it is an extensive property. If they are adding a term, molar volume or specific volume, then it will become an intensive property. Okay, if the word molar or specific is added with any term, then it will become an intensive property. Okay, is this part clear? Is this part clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, one more thing. Intensive property is a non-additive property. You just can't add 2 pH of the solution, okay? And extensive is an additive property. Always. There is no exception. You can add 2 moles, 3 moles, 1 kg, 2 kg. This is the extensive property. This is the additive property. Is this part clear? So consider a room with a wall built in it. If the property change, then if it is called an if the property changes, it is an extensive property. If it remains constant, this is a intensive property. Okay. Okay. Now, this is the thing. Okay, so I guess up to this, everything is clear. Right? Now, from now, from now onwards, if I use the term system, this is our system. From now onwards, if I start using the term system, remember this is the system. This is the piston. This portion is filled with ideal gas. Okay, this is my system. From now onwards, whatever we will be learning, this will be our system. Now, either this piston will be going down or going up. Whatever, with that will vary. Okay. So now, okay, this will be our system from now onwards. So now, let's consider a system. Okay, so previously previously the level was this, but you have put pressure on this piston. Okay, so it has went down. Okay, is this part clear? This is quite understandable to all of you. And this region is filled with ideal gas. Okay, now tell me one thing. If this was the initial condition and I have applied some pressure on the piston, so we are just compressing the gas which is present under this piston. So this gas will be more compressed and will look like this. Yes or no? The
Yes,
gas,
ma'am.
yeah. So this is just the compressed form of the gas. So here we know for ideal gas, we use PV is equals to nRT equation. Okay, PV and T is the variable. This is the constant. So here, the before applying pressure, it was P1, V1, and T1. And after applying pressure, it is P2, it is V2, and it is T2. Right? So, state. This is the state. This is state 1. This is the state 2 of the system. Okay. Now, it what if it is state dependent? Now, if it depends on the initial and the final state, but not on the path of the system. Okay. So anything which is written in delta. Just wait for once. So state function. Sorry for the interruption. So I am discussing about state function. If any property depends on the initial and the final state only, but not on the path, that is referred to as a state function. Anything with delta, with this delta you will remember that it is a state function. Delta H, delta U, delta S, delta G. Delta H means H2 minus H1. U means U2 minus U1. S means S2 minus S1. G means G2 minus G1. So they will just depend on the initial state and the final state. How this initial state became the final state, state functions don't depend on that. But on the other hand, path functions. Path functions depends on the path. How the initial state went to the final state. They depend on path. So it is heat and work. You know what is the definition for heat? Heat is Q, W is work. So heat is energy transfer due to temperature difference and work is energy transfer due to pressure difference. Okay, so this is the simple definition for heat and work. State function and path function is clear to you? Then I will start with the internal energy. Is this part clear to you? Up to this, everything is clear?
Ma'am, can you repeat path function once again?
Yeah, path function means they will, what I told for the state functions like delta H, delta U, delta S, delta G will just depend on the initial state and the final state of the system. But they will not depend on the path which is followed by this system to reach this system. They will just be happy with, okay, the initial system is this, final system is this, I am done with it. But the path function will depend on this path. Path function is bothered with which path this system has chosen to go from this to this, okay?
Okay, ma'am. Thank you.
Okay. Now, can I start with the internal energy now? Internal energy.
Yes, ma'am.
In your book, it will be written as U. But generally, remember, we don't read internal energy. We read change in the internal energy. Change in internal energy. We read only about this change in internal energy, which is represented as delta U. Okay. Or sometimes in few books, you can see it as written as delta E. Okay. So what is internal energy? It is the summation of all energies. So potential energy plus kinetic energy plus bond energy plus all the energies that is present in a system plus all different forms of energy. Okay. Now, this is the standard definition for internal energy. Remember, I guess you know this, potential energy of a system varies depending on the state of the system, right? So absolute value of internal energy can never be determined. We can just calculate the change in internal energy. Okay. So absolute value can't be determined. We can just calculate the change in internal energy. Sorry. We can just calculate the change in internal energy. Now, for your this internal energy, is temperature dependent. And internal energy is a state function. Okay, so these are the basic definitions for internal energy. Up to this part, it is clear what is internal energy? Clear or not? I
Yes,
guess.
ma'am.
So let's start with first law of the thermodynamics. So first law of the thermodynamics is basically the law which describes the energy conservation. What is the definition for energy conservation? Energy can neither be created nor be destroyed, but only can be transformed from one form to another form. This is the law of the thermodynamics, basic law for the thermodynamics. Now, we are reading chemistry. So according to chemistry, internal energy delta U is equals to Q plus W. In your physics, there is something called Q is equals to U plus W, something like this. I don't remember. But this is the definition for your chemistry. Both are saying the same thing, but they are just changing the sign convention. That is why it looks like this. Okay. Basically, we are saying the same thing in either chemistry or in the physics. Okay. Both first law says about the energy conservation. So what is U? U is the internal energy change. Q is heat. W is work done. Now, what is the sign convention? Heat absorbed by the system. Okay, that will be positive. Okay, something I have to write. Heat absorbed by the system. It will be positive. Now, if it is heat is absorbed by the system, means system is being absorbing this heat. That means surrounding is releasing the heat. Yes or no?
Yes, ma'am.
Surrounding release. Okay. Now, heat released by system, it will be negative. Heat released by the system means surrounding will be absorbing it, right? Surrounding absorb. Okay. So heat released by the system will be negative. That means the surrounding is absorbing the heat. Now, work done by the system, it will be negative. Work done by the system means work is done by system on surrounding. That will be negative. But if it is said work is done on the system means work is done by surrounding. Is this part clear? The sign convention with respect to both system and the surrounding. Is this part clear?
Yes, ma'am.
Okay. How you will remember this sign convention? Let's choose this. This is your system. Okay. Work is done on the system, positive. And this is work is done by the system. System is doing the work. Okay. Heat is absorbed by the system, positive. Okay. System is releasing the heat. It is negative. So this is the short form for this. Clear? This part is clear or not?
Yes, ma'am.
This is the short trick. This is with respect to system. If you remember with respect to system, obviously you can do it with the respect to surroundings, right? Now, solve this question. If you have understood this, solve. Find delta U if surrounding absorb 10 kilojoule of heat and do it. Just start doing it or else I will do the sum. Since I don't have much time left, okay, let's just do it. What is the formula? This is our formula. Okay. What is being said? Surrounding absorbs. Surrounding absorbs means heat is released by the system. See, surrounding absorbs. Surrounding absorbs means heat is released by the system. So we will be putting a negative sign. So what from this heat? So for heat minus 10 kilojoule. Okay. What is work? Work is done by the surrounding. Work is done by the surrounding. See, work is done by the surrounding means work is done on the system. So the sign will be positive.
What?
Yeah, so it will be plus 60 kilojoule. So what will be delta U? Minus 10 plus 60 is equals to 50 kilojoules. Okay, so this will be your answer. Sometimes you have to convert it to calorie. Remember, 1 calorie is 4.18 joule. This is something you will be using in your boards, but for the sake of calculation, you will be using 4.2 joules in your exam, and 50 kilojoule means 50,000 joules. So accordingly, you can convert it to calorie, I guess, right? But just by 4 point, divide it by 4.2. Is this sum clear? They can ask you with respect to surrounding, they can ask you with respect to system. So accordingly, whatever they have asked, try to solve it accordingly. Okay? Now, clear? Clear though? Numerical? Clear or not?
Yes,
Yes,
ma'am.
ma'am.
Good, good. So
Yes,
process.
ma'am.
Yeah. We will be learning mainly about 3 processes. Isobaric, isochoric, and isothermal. Isobaric means P will be constant. And since you don't know derivation, P constant means delta P will be 0. Okay. Isochoric means V is constant. So according to mathematical terms, delta V will be 0. And here T is constant. So delta T will be 0. You will be learning about this in your maths class, but for just now, trust me that if something is constant, their derivative becomes 0. Is this part clear up to this? Okay. Now, is this part, just take a screenshot of this page and then I will move to the next part. Okay. So let's start with isobaric. What is isobaric? What I told, what is isobaric? Isobaric means pressure will be constant. Wait. So isobaric means pressure is constant. That is delta P will be 0. And we are always considering a system where I told that the system has ideal gas. Okay. Now, what will be the graph? PV graph, VT graph, PT graph. See, our pressure is constant. So no matter we are, even if we are increasing the volume, the pressure remains same. So the graph will look like this. Okay. So if the pressure is constant, the volume will not change. So the graph will look like this. Okay. So if the gas is being expanded, it will follow this arrow. But if the gas is being contracted or compressed, it will follow this. This is for expansion. This is for compression. Up to this, is this part clear? Clear or not?
Yes, ma'am.
Okay. Now I told you we are always considering a system like this. This region is filled with ideal gas and here is the piston. For ideal gas, we use the equation PV is equals to nRT. Now they are asking about the graph between volume and temperature. Okay, so volume is nR by P into temperature. This nR by P is constant because P is constant and we know nR is already a constant. So this whole part becomes a constant. So constant into T. So it is looking like y is equal to mx. Yes or no? This graph is looking like y is equals to mx. Yes or no?
Yes, ma'am.
Yes, ma'am.
So the graph will look like this. This is for the expansion. This is for the contraction. Now, don't join this part because volume can never be absolutely zero. So just keep some space here. Okay, so the actual graph will look like this. Okay, so this is our actual graph. I hope I made myself clear. Pressure and temperature. Again, pressure is constant here. So if pressure is constant, temperature will not change, right? So it will look just like this curve. This is for expansion. This is for compression. Up to this clear? Isobaric graph, isobaric process and their graphs are clear to you now?
Yes, ma'am.
Good,
Yes, ma'am.
good. Now, next comes isochoric. What is isochoric? What is
Vo-
isochoric? Isochoric
constant.
volume constant. Volume constant means delta V will be 0. So just now tell me the graph. This is PV graph. This is VT graph. And this will be our PT graph. PV graph, see, pressure is same, but volume, volume is constant here, right? Volume is constant. So obviously, pressure will not change. So our graph will look like this. Just a straight line. Okay, so our graph will somehow look like this. This will be an absolute straight line. This is for compression, this is for expansion. This graph is clear to you? Since our volume is constant, our pressure will not change. Similarly here, volume is constant. So our temperature will not change. So it's just the graph will look like this, okay? So it is for expansion, this is for compression. Now again PT. And I told you we are considering the system like that which is filled with ideal gas. For ideal gas, we can use this equation. Now we have to find a relation between P and temperature. P is equals to NR by V into temperature. According to the question, volume is said to be constant. We already know NR is a constant. So it is a constant into T. So P is equals to constant into T. So it also looks like Y is equals to mx graphs. So what is our slope? This is the slope. Okay. And this is your X, this is your Y. Okay. So what the graph will look like this. Okay. This is for expansion, this is for contraction. Is this part clear? Isoporic process graphs.
Yes, ma'am.
Good. And last comes our isothermal process. What is isothermal process?
Temperature is constant.
Yes. Temperature is constant, which means delta T will be 0. Good. Sorry. This is PV graph. This is VT graph. This is PT graph. Now, temperature is constant. Okay. So, volume will not change. So, volume will look like this. Again, temperature is constant. So, pressure will not change. So, it will look like this. This is for expansion. This is for contraction. Now, what for PV? Again, PV is equals to nRT. Now, they have asked you about the graph between PV. So, see, nRT is constant. nR is already a constant. T is also a constant according to our question. So, this entire thing is a constant. So, PV is equals to constant. This represents xy is equals to constant. So, this is a equation for rectangular hyperbola. Okay, you will be learning rectangular hyperbola in your class 12. So this is an equation for rectangular hyperbola. So the graph will look like this. So is it clear why the graph looks like a rectangular hyperbola for an isothermal process? Yes or no?
Yes, ma'am.
Good. So I guess this time thermodynamics is getting clear for you. Now, one more process is there, which is the cyclic process. Cyclic process means where the initial and final states are same. Plus loop is formed. Both the condition should be satisfied. Okay, suppose what I am telling. This is a PV graph for any system. This is A, B, C, D. This is a cyclic process. Means I start from A, I move to B, then C, then D, then A. So this is a cyclic process. Okay. Now, again, it is a PV graph. Now tell me, is this a cyclic process? I move from A, then move to B, then again come back to A. Is it a cyclic process?
Yes, ma'am.
Yes, no, no.
No, ma'am.
A is our initial state, B is our final state. Okay, so this condition is satisfied that the initial and the final states are same. A is moving to B, then from B again it is moving to A. So initial and final states are same. This condition is satisfied, but a loop is not formed. Can you see a loop here? You can see a loop here. But can you see a loop here?
No, ma'am.
No.
No, this is not a cyclic process. On both the condition has to be fulfilled. Then only you can call it as a cyclic process. Okay. One more. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So just give the arrows. Is it a cyclic process?
Yes, ma'am.
Yes. Why?
Loop is formed.
Yes or no? Someone is saying yes, someone is saying no. See, this
Yes,
is
ma'am.
a cyclic process, of course. See, we have started from A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, A. So yes, we are starting from initial state, we are coming back to the initial state. So our initial and final states are same. And you can clearly see a loop. I know this loop is distorted. This loop does not look like a loop, but it is a loop, right? No one said that the loop has to be pretty. This loop can be ugly also. So obviously this is a cyclic process. Got my point, which is a cyclic process.
Yes, ma'am.
Okay, now I will be telling some properties of cyclic process. For cyclic process only, for cyclic process, all state functions. I gave you a list, right? All which are state functions, which are path function. All state functions will be 0. Okay, delta H 0, delta U 0, like delta H, delta U, delta G, delta S is equals to 0. For all the state function. Now, delta U is 0, right? Delta U is 0. And just remember for the internal energy, before starting the internal energy, I told you that the internal energy depends on temperature. Where is the thing? Yes. Delta U is temperature dependent. You remember this? Okay.
Yes, ma'am.
Okay. And what is isothermal process? Isothermal process is where temperature is 0 and delta U is dependent on temperature, right? So delta U will also be 0 for isothermal process. Okay, remember this. So for isothermal process, delta T will be 0 and delta U will be 0 also. Okay, remember, but delta U will not be 0 for phase transitions. For any other transitions, it will be 0, but for phase transitions, delta U will not be 0. Okay. Clear? Up to this, everything is clear?
Yes, ma'am.
Okay.
Yes, ma'am.
One more thing I will say, then I will leave the class. Okay. Irreversible and reversible process. Okay. I will be explaining. Wait. Okay. So what is reversible and irreversible process? So in irreversible process, this is the piston, this is the ideal gas, this is a container, this is a brick. Okay. This is a heavy brick. You have placed a brick and immediately the piston has gone down. Immediately. Okay. So this happened immediately. So the level of the piston goes down, right or not? Yes or no?
Yes, ma'am.
Okay. So, and here what is happening? This is a system. You are putting sand. So obviously this will go down slowly. This will not immediately go down like in the irreversible process. So if you are slowly increasing the pressure, this piston is going down slowly. Okay. So what happens here? The gas is not getting enough time to push the piston back. But here the gas is also exerting pressure on the piston. Okay, so piston goes down slowly, not immediately. Here the piston has immediately gone down. Here the piston is going down slowly. Okay, so this is an immediate process. This is a slow process. This is a one-step process. And this is a multi-step process. Why multi-step? Because you have put multiple sand grains here. 1 grain, 2 grain, 3 grain. So it is a multi-step process. And this is where you have placed one brick. One brick and it has gone down immediately. Here you are putting just bits of sand slowly, slowly, slowly. So it is a multi-step process with infinitely small steps. Okay. This occurs at, so it is a one-step process. This is a multi-step process. Okay. So then it occurs at constant external pressure. Why a constant external pressure? Yeah, this is your constant external pressure. The mass of the brick will never change, right? The mass of the brick remains constant. So it is a constant external pressure. It occurs by variable external pressure because all the grains of the sand are not of equal weight by variable external pressure because all the grains of sand are of different weight. So this is a fast process because immediately it has gone down. This is a slow process. It is slowly going down. Okay. And what is this? It is irreversible. Okay, I have written also irreversible. The change is irreversible and the change is not reversible. So is this part clear? In your question, I am telling you a trick. In your question, the question will be given if you find in your question it is mentioned at a constant external pressure, understand that you have to apply the formulas for irreversible process which we will be doing in the next class. And if in your exam it is said by variable external pressure, understand they are talking about a reversible process. So irreversible and the reversible process, the basics are clear.
Yes, ma'am.
Okay, so whatever I taught you today in today's class, everything is clear to you?
Yes, ma'am.
Good. Okay then. Just learn, and if there is any doubt, you can ask me in the next class tomorrow. Okay? Ma'am, this was from my end. I guess I hope to everyone, Sravani, Harshini, Likhita, Gayatri, Shivani, everyone, this part is clear to you.
Yes.
Good. Okay. So, ma'am, this was from my end. I guess you have to join your next class. That's fine. That's fine. Yes, yes.